From the windy studios of Way Happy, this is Mr. Meyer, and we're doing 9-4 sequences. Sequences are just a list of numbers. It's an ordered progression of numbers, as you see there, and it's just, remember your old chair 2, 4, 6, 8, who do we appreciate? That was a sequence. They can be finite, means we can see how many terms are. There's 4 terms in 2, 4, 6, 8. Or they can be infinite, meaning they go on forever. And what we will do is try to come up with those sequences and equations and define them. Like right in the middle here, you see a sequence can be defined explicitly. It means this. See this equation right here? If you plug in the natural numbers, right, 1, 2, 3, 4, you could build the sequence. So if I plug in 1, I get 3 minus 1, so that's 2. If I plug in then 2, the next number, I would get 6 minus 1 is 5. And then I could plug in 3 and get 9 minus 1 is 8, and so on and so on and so on. Or they can be defined recursively. Recursively means that I will tell you the first number in the list. A1 is a 5. That's the first number in the list. Then you use this little formula right here to tell me the next term, where notice the next term, an, so you say we're plugging in a 2, would be 2 times the term in front of it plus 2. So 2 times 5 is 10 plus 2 is 12. And then say I want to find the next one, would be 2 times the one in front of it, so 24 plus 2 is 26, and so on and so on. So that will define that list. So 2 ways to do it. One is called explicit, where you can find any term you want, just plug that letter in for n. And recursive, the one that has to build on the one in front of it. So I have to give you the first term, and then you tell me, and then I can tell you the rest of the numbers, but I do have to do it in order. All right, how do we find recursive formulas? If you give me a list, well, right there. You'll probably remember these from Algebra 2 or wherever you've seen them. But arithmetic sequence, that's when we add the same number every time. You could also add a negative, so be careful. Then if you want to do explicit formula, use the gray one. D is your common difference, what they are adding every time. So maybe I'll add that. Common difference. And that's what they're adding every time. A1 is the first term. And if it's geometric, when they're multiplying the same number every time, or multiplying by a fraction, so it looks like dividing, you have what's called a common ratio. And so that is your common ratio. That's what they're multiplying by. Recursive in the yellow, you'd have to tell me the first term and then just tell me, hey, the next term is the term in front of it plus d or times r, depending on which one they're doing. So let's see. Here's an example. I give you a list of numbers. First thing I want you to do is look at it and decide, is it arithmetic or is it geometric or is it neither? And then you have no formula and you just have to kind of come up with one. So let's look. It looks like they added 4, and then it looks like they added 4, and then it looks like they added 4 and they added 4. Yep. So I can tell they're adding 4. So right off the bat, I know this is an arithmetic sequence. And now that I know it's arithmetic, piece of cake. If you want the explicit formula, then it's just any term you want to find is the first term, negative 5, plus n minus 1 times the common difference, which we said is 4. And there's your formula. We just like to simplify that up a little bit. So negative 5 plus 4n minus 4, or what most of us would probably call 4n minus 9. That is your explicit formula. That will get you any number in the list, right? Plug in a 1, it should get us negative 5, and it does. Plug in a what? 1, 2, 3, 4. Plug in a 4, it should get us 7. So let's see, 16 minus 9, 7. Beautiful explicit formula. Now recursive, so much easier to make, right? Recursive, you just literally go a1 equals negative 5, and then you say the next term is the term in front of it, and then plus whatever they're adding. In this case, plus 4. Done. There's our equation for recursive. Now what's bad about that? You want to find the 6th or 7th term, you have to build the entire list. You have to find the first term, which is given, but then you have to find the second, then find the third, then find the fourth, then find the fifth, then find the 6th finally. So that's yuck, right? So easy to create, recursive, pain in the neck to use. Explicit, pain in the neck to create, easier to use. What about this? Could you find a recursive rule and explicit rule for the sequence? Blah. So well, let's look. Looks like they added a negative 9. So if they continued that sequence, oh, no, they didn't. So it's not arithmetic. So then if I check to see if it's geometric, I divide. I'm like, all right, -6 divided by 3 would be -2. 12 divided by -6, they get -2. Ooh, 24. Okay, look at that. They keep multiplying by a -2. So kind of a little hint I'll give you there is if you want to find a common difference, you do the second term minus the first term and you see if it's consistent. If you want to see if it's geometric, you do the second term divided by the first term, and that will tell you, get you a ratio, and you can see if that's the same. And that's what I did. We got -2. So I know this is geometric. So I'm like, yay. And R is a -2. All right, what's the explicit rule? AN equals the first term, 3 times R, which is -2 to the n minus 1 power. There is your equation. Do not multiply the 3 and the 2 together because exponents come first. So be super careful. Recursive, also a piece of cake. Give me the first term because you have to. And then just tell me what you're doing. Take any term, take the term in front of it, and multiply it. I guess I should put that in front. So times a -2. So what I mean by that is probably look prettier as -2a to the an minus 1. So that might look a little prettier. So how am I going to box that? That looks better. And there you have it. That's how you find explicit and recursive rules for both arithmetic and geometric. What about if we make it a little tricky? We give you guys like the second and fifth term of geometric sequence, and you find the formulas that way. Well, all that means is there's some number, and then there's a 3, and that was the second term, third term, fourth term, fifth term, right? So they're multiplying by something to get these numbers, and I need to figure out what that something is. I can't tell right now. So here's a little trick that I do. I go ahead and pretend that this is term 1, even though I know it's not. Just for a moment, I'm ignoring this term. Term 2, term 3, term 4. So I know the fourth term is 24, and I know the first term is 3. Well, that should be able to get me R using the explicit formula. So let me put that there. AN equals A1R to the n minus 1. So I should be able to fill in everything but R. And what I mean by that is I know that when you plug a 4 in for n, you get 24. So you get 24 when you plug a 4 in for n. A1 I will call 3. And now I can solve this, right? So dividing by 3, I get 8 is R to the third. Cube rooting both sides, I get R is 2. And now I can tell you what they're doing. And just to make sure, we can say, hey, look, multiply by 2. You get 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And hey, now I can go back and tell you the first term, too. Divide it by 2. So you can call that 1.5 or 3 over 2, whichever you want. And see, now I have the list that they wanted. So I can go through and say, all right, explicit formula is the first term, 3 over 2, times R, which we found out to be 2, to the n minus 1 power. Recursive equation, I can say the first term is 3 over 2, and the nth term is the term in front of it, times 2. So again, I could probably make that look a little prettier and say the nth term is 2 times the term in front of it. Beautiful! There's your right now sequences, and we'll come back and talk about what makes something a series right after this short break. Welcome back, and nice work there. Now let's talk about what if you want to add these lists up. If you want to add these lists up, right, then there's one thing you got to know. If you have an arithmetic, then here's the formula, and it's got to be finite, right? I can't list an infinite list of arithmetic terms because that list would just keep getting bigger and bigger and bigger. So it would head probably towards the concept infinity or negative infinity. So arithmetic, it has to be finite, and there's a simple formula: number of terms over 2 times the first one plus the last one in the list. If it's geometric, meaning they're multiplying by the same number every time, got a crazy little formula: first term 1 minus r to the n over 1 minus r. Also, if it's infinite, and we'll probably talk a little bit more about that, but if it's infinite list, we can actually get an idea of where this is headed. We can sum it up because the numbers are getting so small that we can actually sum it. And we'll probably do that more in class, but there's the formula. It's just the first term over 1 minus r, but I should have absolute value bars. but only works if the absolute value of r is less than 1. And so that's kind of crucial there. So it's kind of restrictive if it's an infinite geometric. It has to have a common ratio of less than 1 if you absolute value it. So here we go. Let's find the sum. So you can see here on this example, I need to decide if it's arithmetic or geometric. So it looks like they subtracted 5. Let's see if they continued that streak. They did. Did they continue? Yes, they did. Yep. So it looks like they're definitely subtracting 5. So I'm going to call this an arithmetic sequence. So the good news is I know a formula, right? But right off the bat, I'm going to be in trouble. S sub n. N is the number of terms. I don't know the number of terms. There's this dot, dot, dot here, right? And that means there's some in between. I don't know how many there are. So good news, I can use that other formula. I can say, oh, wait a minute. A sub n is the first term plus n minus 1 times d, which in our case is negative 5. Now, notice I have two unknowns. I have n, the number of terms, and an, whatever number that is. Like third term would be a 2, or fifth term would be a negative 8. Oh, wait, we know it's negative 38 is the nth term. And we should be able to solve for n, and that would tell us exactly what term number it is in the list. So here I go. Right? First thing I would do probably is subtract the 12. So what is that? 40, 50. So negative 50 equals n minus 1 times negative 5. Now, I was tempted to distribute the negative 5 through, but I'm not going to now. I'm going to just divide it over and get 10 equals n minus 1. Those of you who distribute, that's fine. It's going to be the same thing. And then I'll add, and I'll get 11 is n. So I now know that this is the 11th term. And if I know that, I should be able to sum it up. So I want the sum of the first 11 of an arithmetic sequence is 11 over 2 times the first term plus the last term. Did I put negative 38? Sweet, I did. And so therefore, I can now tell you the sum of the entire series. So the difference between a sequence and a series are added up. So if I do 38 minus 12, that to me looks like 26. So negative 26. And I can take the half of anything, so I'll take the half of the 26. That's 11 times negative 13. And that looks like 130. And another 13 is negative 143. Aww, negative 143. And we jump up and down. We have found our sum. And that looks beautificent. Right? Sorry. What about this guy? Find the sum of the first 14. So again, it looks like an infinite series going on forever, but then they finite it by saying, just add up the first 14. I'm like, sweet, I can do that. So here we go. First thing I want to do is find out if it's arithmetic. So I'll be like, oh, they're subtracting 12. Then they're subtracting 6. Oh, not arithmetic. So then I go geometric. 12 over 24 is a half. 6 over 2 is a half. 3 over 6 is, okay, that is definitely geometric. And our R value is a half. So let's sum up the first 14 terms. So the sum of the first 14 is equal to the first term, 24, times 1 minus a half to the, what were we doing, 14? All over 1 minus a half. And now Virtual Sheila is going to go ahead and take care of this for me. So I will pull her up and say 24 times, and then I will even use my fraction, my fraction button. Oh, come on. My fraction, okay. 24 times alpha f1, all this work just to get the fraction button, which now I don't even want to use. 1 minus 0.5 to the 14th over 1 minus 0.5. And Sheila tells me it's about 47.997. So about 47.997. I should put squigglies here, huh? And then say, there's your sum of the first 14. Just for fun, I could tell you that we could sum up this infinite list too. Because of the fact that r was less than 1, we would be able to find the sum of this list. And that's a really simple, and I mean going on forever, because see how these are getting so much smaller, 3, and then the next one's going to be 1.5, and the next one's going to be so. These numbers over here are going to get so small that they're not even going to add to the total anymore. I mean, they're going to be ridiculously small, and so they just don't even count. And so we can get a limit of this number about where it's headed, what number it's called converging to, by just doing the formula a1 over 1 minus r. Again, you can only do this if r is less than 1. So I have 24 over 1 minus a half, which would be 24 over a half through the magic of copy.flip. 24 times 2 over 1, which is 48. This number converges on 48, and you can see at 14 terms, we were already close to 48. It's saying that, hey, if this list goes on forever, the rest of those terms won't add up to diddly poop, right? And so that's kind of a neat thing and kind of a crazy thing to wrap your head around. So we can definitely discuss this. I just wanted to let you know that if it's infinite, we can find the sum. It's called convergent. If it's not, it's called divergent. Ooh, that's not good at all. It's called divergent. A little fix there, so make sure you scribble that out and call it divergent. Usually you will decide if r is less than 1, you will go, oh, it converges. But if they give you some equation that you can't tell because you can't find r, then all you have to do is kind of use some of your horizontal asymptote rules. Will also tell you if it's divergent or convergent. Anyway, have a great day. Stay happy, and we'll see you later.